All right, here's AP practice number 7. So we have the temperature outside a house during a 24-hour period is given by this big function from 0 to 24. Note we have some trig in there. And we're asked first in part A to sketch the graph using this particular window. So that's what we're going to try and set up on our calculator. So this again is a calculator-based question. Probably the couple of things to remember here is make sure your calculator is in radians because we are working with the trig function, and then use the scale that they're giving here. Now I always like to on my window show maybe a little bit less and a little bit more. I may go to 30 and 110, maybe I go to 50 here, but just so you can see all of this on your window. Once you've done that, it's really just plotting in some points like 0, 6, 12, 18, 24, and getting the general shape of this. Right, so this is a calculator question. Let's just go ahead and punch that into your calculator. I'm assuming now you all can work through your calculator, so I'm not actually going to show the calculator screen on the video anymore. But I've punched in 80 minus 10. I've checked my mode, making sure I'm in radians, and I've gone ahead and I'm showing the window that I've described here. Okay. And when I graph that, I see my cosine curve. I'm going to plot some points. So I'm going second function, calculate, and I'm doing some values. And I'm going to punch in 0, and I get 7. So I'm going to, or 70. So I'm going to put in that point at 70. I'm going to go ahead and do 6. Now we've said on a previous video that we don't have to go second function calculate each time. As long as we know we're in value, the calculator understands you're in values. So if I just punch in 12 and enter, it knows that I'm still in value, and it gives me that value of 90. I go to 18 and we're back to 80, and I go to 24 and we're back to 70. So now it's just a matter of kind of sketching that curve on here as we go. Try to get up into there. And we have our cosine curve. Okay, so we still have this function, and we want to find the average temperature to the nearest degree. So they're always going to tell you, do we want nearest degree, the hundredth of a degree, thousandths of the degree. So they're talking about decimal places in our final answer. And this is between 6 and 14. Time equal to 6 and 14 hours. All right, so average. Let's just recall, first of all, my average value of a function, b minus a, from a to b of our function. So there was our average value of a function. So that is in fact what we're going to do here. So this becomes from 6 to 14 of our function. I'm just going to put f of t dt, and this is 1 over 14 minus 6. So on my calculator, this first part here, or this part right here, I'm just going to go second function, calculate, and then number 7 is the integral. So that's what I'm going to go through right now. So I'm going second function, calculate, I'm going down to number 7, and my lower limit is 6, my upper limit is 14, and it's going to shade all of that area in. And now I have 1 over 14 minus 6 is 8 times all of this that I just found, 697.29578. And on my calculator, what I'm going to do is hit answer. So it will take that answer, and I'm going to divide it by 8, or multiply by 1 over 8. And I end up with an average temperature of 87 degrees Fahrenheit. That's to the nearest degree. Okay, part C. An air conditioner cooled the house whenever the outside temperature was at or above 78 degrees Fahrenheit. For what values of T was the air conditioner cooling the house? Okay, I'm going to start by bringing back that graph we had just so we can kind of see. So this was our graph that we made earlier. So when the outside temperature is above 78 degrees, so 78 degrees is going to be in here somewhere. When it's above 78 degrees, the air conditioner is going to turn on. So what values of T was the air conditioner cooling the house? So what we're looking for here now is that intersection point there and there. When during the day was it actually cooling our house? So now on my calculator, I already have the function curve. So I already have this one sketched in my y equals. I'm now going to go to y2 and I'm just going to punch in 78. Now, when I graph this, I can see that black line, and I'm going to find the intersection. So second function, calculate, and we're looking for number 5, which is the intersection. So that's what we're looking at. Now, you don't have to write this down on your exam or anything, but that's what we're going about doing. So second function, calculate, intersection, that I'm going to go from my curves. Now we're going to find 2 of them. So at the point where it says guess, I am actually going to scroll over and make sure I'm close to this value here. And when I do that, I have time equal to 5.23 hours. And then I want to find the other one. I'll call that T1, T2. I want to find this one. So I go through that whole thing again. Second function, calculate, number 5. I have my 2 functions, but again, when it comes to guess, I'm going to make sure I scroll over and get my cursor somewhere close to this one here. And when you're done, it'll put the cursor where it's giving you the answer. So we've got to make sure it's giving me this one and not just 5.23 again. Now I have 18.77 hours. Okay, so what values of T? I'm just going to write my final answer here. There's T. We're looking at greater than 5.23 and less than 18.77 because it says at or above, so I'm actually going to put in my equal signs because that's when it would be at 78 degrees and at 78 degrees. And finally, part D of this question, the cost of cooling the house accumulates at the rate of 5 cents per hour for each degree the outside temperature exceeds 78 degrees Fahrenheit. What was the total cost to the nearest cent to cool the house for this 24-hour period? All right, your final part of any of these questions are really going to get into the applications and extend our thinking a little bit here, right? So this is the cost of cooling the house, and it is for at a rate of 5 cents per hour for every degree that it exceeds 78. So it's kind of hidden again. Let me go back and bring up our graph one more time and show you what we're talking about on the graph. So this is our graph. We actually added in that 78 degrees in there. And what we're saying here now is for all of this, it is going to be 5 cents. So again, let's think. I'm going to get rid of that little bit. Let's show that one more time. So there's our 78. So just think in right here, whatever that is, the degree difference times 5. And then in this little section here, that degree difference, each degree where it exceeds 78, the degree difference times 5. This degree difference times 5. This degree difference. So it's all of this, whatever that difference is, times 5. So what is that going to look like as a calculus equation? Well, we're looking for the total cost now is going to equal that 5 cents for this whole area. Now we just figured out that it was 5.23 all the way up to 18.77. That was our area. Now always check, I put 2 decimal places here. A lot of times calculus may want 3 decimal places. Okay, so if we had the zeros or this was 769, just check the questions. But we're going over this interval from our endpoints that we just found in part C of our function. Now it is actually the function that we had minus 78 degrees. So that's what we're looking for because it's just bigger than the 78. We don't want everything all the way down here. We don't want any of that. Okay, so this is calculator again, but I got to make a little adjustment. I'm going to put in all of this in my calculator. So I'm going back to y equals, and I have 80 minus cosine x squared, or sorry, pi x divided by 12, and then I need to subtract 78. Now that's what I want to graph. I'm also going to make sure that I clear out the 78 that I had before. I don't want to see this black line. So really what we're going to do is take this whole thing here and shift it down. So we should see something now that is doing this at 0. And we want to be able to find this part. So that's what we're looking at here. So I'm going to graph that. Now I'm going to have to change my window. Okay, so I'm going to my window. My x values are still the same. I still want to go from that 0 to 30 or so, but now I want to see the 0. I usually go a little bit lower, so I'm going to set it at minus 10, my window at minus 10, and up here I'm going to go to maybe 20. If it doesn't work, if I don't see the top of it, I can always just change that. I got plenty here. Okay, so now I'm going to go ahead and graph that. And one thing that you can look for, just to make sure that you've punched in everything correctly, these points here were intersection points. They should show up as zeros in this new graph. Once we put this section minus 78 in here, those points should be zeros of our graph. Okay. So check that out. Now I'm going to go back to second function calculate. I'm going to do number 7 again to find the area in here. So I'm going to set my lower limit at 5.23, my upper limit at 8.77. And the calculator is working. My cost then is going to be 5 cents times, this is 101.927, just keeps going. So I'm going to put answer times 0.05. And the cost of running my air conditioner in dollars will be 5.10. It's money. So let's put that as 2 decimal places. All right, so that was a little longer, a little more thinking there in part D to really figure what they're trying to tell us. What you will note is a lot of times when they tell you that it accumulates at a rate, really accumulates at a rate, that means we are trying to find some area. All right, we're adding together. It's accumulating all of those rates of change. It is the sum of all of these rates of change. All right, good luck. I'll keep posting some more. Practice, practice, practice.